Welcome. So we're going to be talking about independent events. And let's begin with a classic example here. Let's consider tossing a coin twice. What is the probability that the second toss shows a head, given that the first toss shows a head? If we define A as the event the second toss is a head, and B as the event the first toss is a head, then what is the probability of A given B? Well, we know that the probability of A given B is the probability of A intersection of B over the probability of B. The probability of A intersection of B is simply the probability that both tosses show a head, and we know that the probability of B, as defined here, is simply the first toss shows a head. Let's draw a tree diagram to help us out here for a second. So we've got head or tail as my first toss, then head or tail, head or tail. Perfect. And if we want to find the probability of A intersection of B, we know that's simply tossing two heads. So going like that. We know that this is going to have a probability of 1 on 4 because there are 4 different outcomes here. Head, 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 tail, tail, head, tail, tail. So the probability of getting head, head is 1 on 4. No dramas there. We also now, and that's why I'm putting 1 on 4 there. And then what's the probability that the first toss shows a head? Well, that's just 1/2, just like that. So if we go a quarter over a half, that's equal to a half. Now this is interesting, isn't it? Let's read this. That is, the probability that the second toss showing a head does not seem to be affected by the outcome of the first toss. This is an example of independent events. So to boil that down in really simple English here, what it's saying is the second toss is not affected by the first toss. These are two independent events. You may have heard people say, if they're like flipping a coin many times, let's say they've flipped it 3 times and they've gotten all heads. And they might say, well, it's about time we get a tails now. Surely it's more likely that we're going to get a tails now. That is wrong. That's incorrect. That's known as a gambler's fallacy. Every time you flip a coin, there are 50-50 chances of you getting a head or a tail, regardless of what you threw right before it. It has no effect on it. If we're to dive into this a little deeper, what we're trying to get here is this, the probability of tossing a head a second time, and we know that we can represent this probability as the probability of tossing a head a second time, which is A, given that the first toss is a head, which we've defined as B. But we know that's simply going to be the probability of A. The second toss is a head because it's just 50-50 chances every time. We know the probability of A given B is simply going to be a half. So the moral of the story here is independent events are events in which one thing does not affect the other. So the outcome of one result or the outcome of one event does not affect other events. That is an independent event, and this is the classic example known as the gambler's fallacy when you're flipping a coin.